So, in terms of inverse trig functions, this is all about finding angles in right triangles. This is when we use these. So let's just say I have a right triangle, and I'm going to make it a simple one because I'm going to use a Pythagorean triple, 3, 4, 5. And in my pretty little right triangle, which I'm going to call QRS, I know, for instance, that, let's see, the sine of Q is 3 over 5. Or the cosine of Q is 4 over 5, and so on. Okay, so if I have side lengths, then I can figure out what the sine is and what the cosine is. Those are the answers for sine and cosine, but I don't actually know what this angle is. The purpose of having an inverse trig function is to find the angle, because it's like I'm trying to solve this equation. If the sine of Q is equal to 3/5, it's like I'm having to try and figure out how to get the Q isolated, how to get Q by itself, which means how to get sine away from it. This is not an equation like this, where I can just say, oh, just divide both sides by 5. Sine is not a number. Sine does not have any meaning by itself, so I can't just take the sine away. I have to do the opposite of sine, basically. That's called the inverse sine. So I can take the inverse sine of both sides. So let me make this a little bit bigger so I can squeeze in. The inverse sine. If I take the inverse sine of both sides, inverse sine of this over here, and inverse sine of this, then this inverse sine and the sine cancel out, which leaves me just Q. So Q is equal to the inverse sine of 3/5. Inverse sine just basically means I'm working backwards. Okay, let me give you an example of that. Let's say instead of this scenario that I have a triangle, and it's a right triangle. And in my right triangle, I know one angle, and that angle is, oh, I don't know, a 40-degree angle. All right? So, for instance, let's say this side is X, and I don't know, well, I don't know that one, and this one's 10. Then I could find this missing side length by setting up an equation, because this is this, for this angle, this was the opposite side, this is the hypotenuse. I can use sine and say sine of 40 degrees equals X over 10. So to isolate my variable this time, I'm not trying to get the sine away from the angle. I can just cross multiply. This is what I've been doing. So when I cross multiply, I get 10 times sine of 40 equals X. So 10 times sine of 40 gives me 6.43. Let's just call it 6.4. So X is about 6.4. What that means is the sine of 40 degrees is about 6.4 divided by 10. 6.4 divided by 10. Let's suppose we have cosine of (57 degrees) equals, and I'm just going to round, but I'm going to put equals 0.54. I'm just getting tired of squiggly lines, but all of these are approximate. So that means then that the inverse cosine of 0.54 should give me 57. which it does. If in my calculator, if I press cosine of, and this is how I got this, if I press cosine of 57, there we go, if I press cosine of 57, I get 0.54, so on. If I do inverse cosine of that same number, as a matter of fact, I'm going to do it on my calculator so that it's exactly the same number, not the rounded one. I'm going to do inverse cosine, then I'm going to get the answer that I just used. I should get 57. It's saying the inverse cosine of 0.5446 da 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 gives me 57. One way of looking at that, instead of the actual what's happening, if we showed solving it, we would do inverse cosine of both sides, and these cancel. But instead of doing it that way, one way of thinking of this is, if the cosine of 57 degrees is equal to 0.54, it's like you're picking up the cosine and moving it to the other side, and it becomes an inverse cosine in the process. So just like when we're solving equations and we say, well, if you move it across the equal sign, it changes signs, even though that's not really what's happening. If I have cosine of, let's call it angle x, equals, and again, this is approximate, and I'm just going to randomly pick something. How about 0.19? If the cosine of x is equal to 0.19, then I can move this over here to get x alone by making it an inverse cosine. So inverse cosine of 0.19 should give me x. So inverse cosine of 0.19 says that x is about 79 degrees. So what that means is the cosine of 79 degrees is about 0.19. So we can use this when the variable is right here next to the sine, cosine, or tangent, because we're trying to get the sine, cosine, or tangent unattached from that variable. So in context, we use it when we want to find the missing angle. So let's say we have a right triangle. Let's do one from our homework. If I can find one real quick. Here we go. Let's do number 6 from the homework. Number 6 from the homework gives me a right triangle that looks a lot like the one I already drew, so that's why I'm using that one, and asks me for this angle. Okay? You always set them up the same way we do if we're finding a side length, and that is cosine of blah 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 equals adjacent over hypotenuse, or sine of blah 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 equals opposite over opposite over hypotenuse, or so on. You use the definition to set up a proportion. So in this case, I'm going to go ahead and just call this x, and this is the hypotenuse, and this is the opposite. So I know that I'm going to use sine, and I'm going to set up that blah 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 equation. Sine of x equals opposite over hypotenuse. And then to find x, again, it's like I'm just picking up the sine and moving it over here. If sine of x equals 33/35, then x equals the inverse sine of 33/35. We don't have to change it to a decimal first. We can put it in our calculators just like that. So it's like we've moved the sine over here. It becomes inverse sine in the process. Inverse sine of 33 divided by 35 gives me 70.537, or 71 degrees approximately. So x is about 71 degrees. That says if I took the sine of 71 degrees, I should get something that's about the same as 33 over 35. So let's do sine of 71 degrees. That gives me 0.945. And if I divide 33 divided by 35, I get 0.942. So it's very close. It's just a rounding difference. Okay, let's do another one from the homework. Let's see, how about number 5? Number 5 on the homework starts out, we have a right triangle. We've got 16 here and 22 here. And unfortunately, this is going to be a sine again. So let's not do this one. This will be a sine again. Let's do number 3 instead. Number 3. We've got a right triangle. This is a 42. This is a 56. And this is my x. It's the question mark. And so for this angle, this is the hypotenuse. This is the adjacent. So I'm going to use the cosine. So when I set up my equation, I say cosine of x equals 42 over 56. And I don't have to change that to a decimal or anything. It's fine the way it is, because this means that x will equal the inverse cosine of 42 over 56. And that's what goes in my calculator. I'll do inverse cosine. If I can get it set up, inverse cosine of 42 divided by 56. Enter gives me 41.4, or about 41 degrees. Every time you do an inverse function, you find an angle. That's the only time you need the inverse function. When you're finding the side lengths, you do not need inverse sine, inverse cosine, or inverse tangent. You still just use regular cosine, regular tangent, regular sine, etc. So this is the only time you need inverse, is when you're missing an angle and need to find it. That's about it.